Okay, so Friday, week 15, big day. Today, we are on our final topic, and again, it's a good one. Interference from two sources. Imagine sound, okay? Take your two speakers and set them up. The idea in this section is that if these speakers are emitting a constant frequency pulse, okay, a sine wave, okay, what's going to happen is those waves can interfere. And depending on where you are in the room and the relative separation between those two speakers, either the waves will interfere constructively or they may interfere destructively. Maybe something in between, but we'll focus on constructive or destructive, okay? So, think about the arrival of those waves where you are, okay? If they arrive in phase, that if they're separated by a single wavelength or a multiple of that wavelength, you hear a loud frequency, okay? However, if the two waves arrive at your place, a half a wavelength separated, then we get destructive interference, okay? So this idea about interference really comes down to when the two waves arrive. If they arrive in phase, you'll hear a loud frequency. If they arrive out of phase, a half a wavelength apart, you hear destructive interference, and the frequency will be quiet, okay? So we'll use equations in the text combined with plots and concepts to sort of strengthen our understanding, but you may need to work a little harder in this section as you probably don't have a lot of intuition about this. I don't think you've experienced it in any other class. I like slide 1631. Okay? The idea here again is the principle of superposition. You've got two waves. In this case, I'm just going to imagine two speakers that are sort of separated in distance. Okay? In that figure in the middle there, if the speakers are separated by a wavelength, delta D is a single wavelength, then what you'll get is constructive interference. However, on the figure on the right, if the speakers are separated by half a wavelength, then you'll get destructive interference. That's a simple enough place to start, okay? We're going to introduce a slightly more complicated notion of this. We're going to put the speakers out in space, but the idea is the same regardless, right? You're going to think about the path length difference, okay? If that path length difference is a wavelength, or two wavelengths, or three wavelengths, or a whole number of wavelengths, then we get constructive interference. If it's a half a wavelength, or three halves, or five halves, we get destructive. Okay? Try to make sense of this. This will be our last video for this class. I hope that they've been somewhat helpful, at least guiding how you're digesting the material. But I look forward to seeing those of you who will be in class next semester. But on a personal note, it's been a real pleasure getting to know all of you and working with you. I know this has been a long, tough semester, but I've been really proud of the work that you've done. And let's keep it up for just these last few days.